Education Congress Award for 50 Women Leaders in Education 2018. I would now request ma'am to please take over the session.
Thank you very much. Um, it's really amazing. I hope I'm audible. I hope I'm audible.
Yes, ma'am, you're audible.
Yeah. So thanks and good morning to all of you. It's such an amazing thing that, we are all there in the comfort of our rooms. In fact, I'm still in my bedroom. So that's the beauty of technology. What do you say? I mean, that's really the beauty of technology, that we are able to connect despite so many constraints and so all over the world. So warm welcome to all of you. And I think I'll start with this lecture on machine learning. So when we talk about machine learning, we are so phased up. We are so stuck up with CNN, neural network, CNN. We forget that there are some other beautiful techniques which are not so heard of, which we haven't heard of so much. I hope my screen is visible. I'll put my video off now. Is my screen visible, Manish ji?
Yes, ma'am.
My presentation is visible?
Yes,
Yeah.
ma'am. Your
Yeah.
presentation is visible.
Yeah, yes. So as you can see, the title, Machine Learning, Probabilistic and Approximate Techniques. So I'm really going to dwell today on that aspect. No CNNs, no convolutional networks, no BERT, no LSTM, no attention networks. There are some other techniques which are equally powerful and in fact much more computationally simple. We'll focus on them. So the first thing that I'll quickly browse through and I'll quickly say, what all we have done, me and my co-researchers have done in this area. So you all know the basics. I'm sure it's the third day of the FDP, and in any case, you know what is machine learning all about, and that there are supervised techniques and unsupervised and reinforcement learning, lots of techniques, and now transfer learning also. So many types of these things are there. Techniques are there. What we will talk today is about these probabilistic and approximate techniques. And just a second. I think I am on the wrong slide. Just a second. Yes. So we will talk a little bit about this theory called rough set theory. And this is a paradigm for approximate computation. You must have heard of fuzzy logic. So fuzzy logic is actually for imprecise computations or overlapping computations, and both these rough set and fuzzy logic together stand for what we call these approximate techniques. The father of fuzzy logic was Zadeh, and the father of rough set theory is Professor Z. Pawlok. And it was a very interesting time when both of them met together and shook hands and said that, okay, fine, here we have a completely new, different paradigm for computation where everything is imprecise and fuzzy and approximate and overlapping and confusing. And yet there is a beauty behind it. There is a mathematical elegance to it. Aisa nahi hai ki we say that, okay, we are doing things approximately. There's a mathematics behind it. So let's start with this example. I hope I'm in the slideshow mode.
Yes, ma'am.
Because, yeah, I have two screens actually. And in one screen, it is not in the slideshow, and the other it is. So I hope you're able to see the side screen, the slide
Yes,
screen.
ma'am.
It's moving, not moving here. Just a second. It's not changing this. Yeah, here you are.
Okay.
So just as this thing, as a motivating example or example we all are in, अभी lockdown चल रहा था कुछ दिन पहले. Now it's all opening up. But one of the important decisions that we might have been making is whether to go from one city to another. I mean, all of us suddenly stopped traveling. and yet traveling is so important. So, we started thinking about, okay, fine. So there is one city one and city two, and we want to move from one city to another. Okay, and then we have these instances. This is the training data. This is the training data, and we have these instances. We have these instances. Just a second. I'm seeing my pointer. I don't know why my pointer doesn't work. Let me use the laser pointer here. Let's say there is a full lockdown, and in some cities there are partial lockdowns, and the phase of corona, whether it's the starting phase and all that. So these are the various parameters, and the decision that I want to make is okay to travel or not. And if there is a new case, what kind of decision, so you have an unlock condition, and the phase of corona is accelerating. You have this aircraft as a mode of travel, and there are a lot of positive cases in the starting city, in the destination city also. Destination city has poor hospitals and poor habits of the citizens. तो इस तरह से मैंने कुछ डेटा अगर कलेक्ट किया, I want to make a decision. How do we make a decision? So we make a decision in a very approximate manner. We don't say, I mean, ये हमारे पास data तो है. All this data is now this particular instance is not matching with any of the instances that are already there. So how do we make a decision? So, so do you realize that we as human beings really don't see so much कि phase of corona भी देखना है, travel ये वो, then we'll not be able to make a decision at all. So we partially, some of us see, okay, fine, destination city में hospitals या habits of citizens कैसे हैं? Is it safe or not safe? If the habits of the citizens in the destination city is safe, then I might as well go, because in any case there is unlockdown. Somebody else would probably think there is a lot of positive cases in the destination city and in the start city also, and I don't have that much of money to go by air, and therefore I'll not travel. So see that there's already a feature elimination that is going on in our minds. And when we start doing feature elimination, and now let's say I take lockdown status and travel mode, right? And I find that unlock यहाँ पे भी है, यहाँ पे भी है, unlock है, and air travel यहाँ पे भी है, यहाँ पे भी है, and the decision is yes. So would I take a decision yes here? Is the question. Okay. So now the basic problem that occurs is, how do I choose which features to take? And that's where the rough set. So rough set is essentially a supervised learning technique, and it does feature elimination, and it has an approximate method of computing. So we'll see how that occurs. So rough set is actually fundamental to all these fields: artificial intelligence, data science, machine learning, knowledge discovery, decisions, and there are so many applications to it. You can have your own application in medicine, in economics, in environment, in engineering. Lots of application areas are there. And so let's start with the basics. I already gave you a motivating example where we have to make a decision whether to travel to some destination city or not during lockdown. So I'll take an information system. This is called an information system, where you have all these information. So I have, this is a very standard example taken for most of the machine learning, when we start learning about decision trees, etc. तो मैंने वही वाला example उठाया है. And you find that there are some condition variables: outlook, temperature, humidity, and wind. And the decision one has to take is whether to play sport or not. So an information system is a universe where there are some attributes, condition attributes called A, and there is a decision attribute, which is D. Now, during my presentation, if you want to ask any question, you are most welcome. The moderator will take care of it. I don't mind being interrupted. So these are the instances. Okay.
Participant, if you want to ask any question, then raise your hand because you all are muted. Okay, ma'am, you can proceed.
There's something. My presentation is not responding for some time. Wait just a second. Give me a second. Suddenly it says not responding. I hope I'm audible still.
Yes, ma'am, you are audible.
Yeah, but then there is something happening to the. Let me use my other one. Pata nahi kya ho raha. Okay. Why isn't it responding?
Ma'am, if you say I can share your screen.
No, it will be a different one. Microsoft PowerPoint is not responding. Restart. Wait for the start. So just should I restart?
Okay, ma'am.
It is just not responding.
Okay, you can.
I think I'll restart it.
Okay, ma'am.
Restart the program. So in the meantime, I'll restart again. I'll stop sharing and I'll start again. I'll have to open my presentation again. Yeah, is my screen visible now?
Ma'am, presentation is not showing.
Yeah, presentation I'll show. I'll just come to the presentation.
Now it is visible, ma'am.
Yeah. I'm sorry about all this. I don't know how it stopped responding completely. तो ऐसा है कि yeah. So you see what happens is there are two decisions, no and yes, and some of the instances belong to the no part. Like these are the no decisions and these instances are the yes decisions. So what I can do is these two yes and no. As you can see in the previous slide, there are some no's and there are some yeses. Yeah, these are the no's and there are some yeses. And this is what we see in the real world. They are realistic decisions. So we take them as crisp sets. So I have two crisp sets, no and yes. Okay. And these instances belong to one of the two. However, when you find when you find the instances, for example, all of them are different instances: sunny, hot, high, weak, sunny, hot, high, strong, and so onwards. All right. Now, what we start doing is we try to simplify the table, and we try to make equivalence classes. So the basis of equivalence classes is indiscernibility relation. Indiscernibility relation is, those instances which are similar in every way in terms of some of the subsets of the attributes. For example, there are two instances, this and this, sunny, hot, high, high. So these two are exactly equivalent in terms of three attributes: outlook, temperature, and humidity. So in general, if I take a subset of the attributes B, which is a subset of the total number of, condition attributes, then the indiscernibility relationship is defined in this manner. It's the pair of all instances in which they are similar in all the attributes. So what we start doing is we start making equivalence classes. So these are the indiscernibility relations. You have indiscernibility all null, because if I take all the attributes, none of them are similar. All of them are distinguished from each other. However, if I take outlook, temperature, and humidity, then I find 1 and 2 to be similar, 4 and 14 to be similar, and 5 and 6 to be similar. So I have these three indiscernibility classes. And from the point of view of these indiscernibility classes, we have what is called equivalence classes of a particular member X. So if I talk of equivalence class of 1, so the equivalence class of 1 is 1 and 2. All right. Equivalence class of 5 is 4, 5, and 6. And equivalence class of 14 is 4 and 14. So every element has its own equivalence classes. All right. Now, once again, it's not responding. Gosh. Yeah, it's taking some time to respond today. So if I now take my crisp concepts, the real world concepts, yes and no, and now what I do is I have all the individual instances and I put them in these classes. What do I find? This is what I find. Now here you see that case, rain, hot, high, strong. And if I compare it with each one of these cases, it doesn't match with any of those cases. Therefore, I will not be able to classify this new example because it doesn't match. If we see carefully, then every example is a rule that if the outlook is sunny and if the temperature is hot, if the humidity is high, and if the wind is weak, then we will not go in for sports. But the point is, what about this new case? Now, so if I put each and every instance separately, then there are some in the no case and there are some in the yes case. And we find that we are not able to classify the new one at all. Now, this is where the classification accuracy is going down. You have so many examples, yet we are not able to classify a new example. So what we do is we have already made equivalence classes, and now we try to reduce the number of attributes. So one is, clubbing together in the instances to make equivalence classes, and the other is to eliminate the unimportant features and to club together only the relevant features, right? So what we do now is we take the equivalence classes, like for example, I have taken temperature and humidity as the two attributes. Okay, so these three are equivalence classes, these three are equivalence classes, and these two together make an equivalence class. So you see there are three equivalence classes. And then we try to match it to the decision variable. So this equivalence class has three instances, 1, 2, 3. However, two of them have a no decision and one has a yes decision. That is when we say that the whole thing is rough. That means these pair of these set of instances, some of them do play sport and some of them do not play sport. If you take this equivalence class, all of them, one of them plays sport and two of them do not play sport. So once again, it is rough. However, if you take the last equivalence class, both of them do play sport. So if I now match these equivalence classes rather than individual instances. Earlier, we had taken individual instances, and now what we do is we take the equivalence classes and we try to match them. Then what do we find? We find that, yeah, this comes, one of them comes in no, So we match the equivalence classes. So from here, the earlier one, from this where every individual was placed individually and therefore everyone was either in or out, we come to this particular case where they are all overlapping. Some of them come to no and some of them come to yes. 10 and 11 is definitely inside. 13 is definitely inside, but all the others are in the boundary region between yes and no. Now, if I ask you, if I just ask a question that, do you think that this is good for classification or not good for classification? ये वही वाली बात हो जाती है जो हमने शुरू में लिया था, that we want to move in COVID times during lockdown or unlockdown or partial lockdown from one city to another. We just want to move. So the question is whether we should move or not move. अगर हमने सारे parameters देखे होते, if we had seen all the parameters, we wouldn't have been able to make a decision. But if we take reduced number of decisions, we are able to make a decision, right? Now, can you now tell me, using this example, I've taken only two parameters, temperature and humidity, okay? And I've ignored outlook, I've ignored wind, and I've taken these equivalence classes, and now I'm trying to match them to yes and no, my crisp decision class, real world mein jo ho raha hai. Do you think that this is good for classification? Classifying the new example. Anybody can volunteer? Because that's an important question. I'll tell you why. This question begs attention. We have read about overfitting and underfitting in some other techniques. When we are talking of approximation method, तो fit करने वाली बात नहीं आती. Everything is approximate. So yes. Anybody would like to venture?
I think it cannot be a good classifier, ma'am.
Okay, what's the reason?
Because we are considering only two attributes.
Okay. Now, because we are considering two attributes, what happens is that the equivalence classes sort of fall partially into yes and partially into no. And therefore, but then what about this new case? Rain, hot, high, strong. So we are taking hot and high. All right. These two attributes, temperature and humidity, and hot and high के तीन cases हैं हमारे पास. Hot and high के 1, 2, 3, and this is the class. So don't you think I can now put it in this class? So now there is an anomaly. Now there is a dichotomy. Earlier, जब हमने अलग-अलग लिए थे, when we had taken all the attributes, तो वो सारे individual थे. They were all individual. And we were not able to match it with any example. When we reduce the number of attributes, then what happens is at least it matches. Hot and high ka class hai. And therefore, we are at least able to put it in this. Okay. However, yes, Manish, you're right that this is approximate. Now, that is where what we mean when we say approximate methods, because two of them are no, and one of them is in yes class, two of them. So the new one, maybe we put it in the no class because there is a majority for no class, but at least we are able to classify. So the dichotomy here is the same as what happens in underfitting and overfitting in deterministic techniques. What's happening is, on one hand, if I take things too accurately, if I use all the attributes, then we are not able to classify. Okay. On the other hand, if we start reducing the attributes, then we have bigger classes, larger classes. But those larger classes now occupy both the crisp decisions, yes as well as no. At least we are able to classify. So but the classification may not be accurate. It has to be an approximate classification. So the dichotomy is between no classification to approximate classification. If we take things too accurately, जैसे COVID वाला example अगर हम लें, then if we take all the conditions, then we will not be able to make a decision at all. लेकिन अगर एक दो attributes लेंगे तो roughly हम कोई ना कोई decisions ले सकते हैं. So just like we human beings make approximate decisions by taking some of the important attributes and drop the unimportant attributes, rough set theory actually allows you that. It tries to make equivalence classes on the basis of less number of attributes and then classify. So though the classification accuracy may fall. Now, the second question that arises is, So we see, these are called redux. When we drop attributes, it is called redux. So we have bigger equivalence classes, lesser rules, more support per rule. पहले जो है यहाँ पे there was only one support for every rule. One support. There were how many? 14 rules. There were 14 rules, and each one of them was supported by only one example, and yet we were not able to classify a new example. Versus this one, where there are just 1, 2, 3, 4, 5 rules. There are just 5 rules. Each rule has more support. There are 3 support for this, 4 support for this, and so onward. So that the support for the rules is more, okay, and we are able to classify. So that's what I mean, that there is more support per rule and greater roughness. So there is a chance that we can misclassify also. But then the fact also remains that there is more chance for actually doing the classification. Okay. So we have already done equivalence classes and redux, right? And let's take a bit more of the terminology. So we say that there is approximate, we say set approximation, or rough set is all about set approximation. There are 2 sets there. One set is what, those equivalence classes which are surely in the crisp classes. This is called the lower approximation. All right. So I have a decision variable xd. In this case, it was yes versus no. All right. So each of these decision variable has a lower approximation and an upper approximation. तो होता यूं है कि real world में there are real decisions to make. Real world में you actually have to make a decision. It has to be either yes or no. It cannot be yes or and no, both of them. So it has to be some real decision. Now that each of these real decisions is approximated by 2 sets of attributes. One is the lower approximation, one is the upper approximation. Lower approximation is all the equivalence classes which are a subset of the crisp decision, and upper, so this is a subset. The equivalence, all those x's whose equivalence classes is a subset of the set of decision variables. And likewise, there is an upper approximation where it is not exactly inside, but which may be partially inside, partially outside, and hence it overlaps with the decision class. So the overlap is not empty. All right. So if I take this example, you have, this is a lower approximation because this equivalence class is completely inside the yes class. Whereas these, and 13 is also in the lower approximation. However, this, and this are upper approximations. In the no class, there is no, this is the no class, and there is no lower approximation at all. Andar koi bhi nahi hai, but overlapping ye sare ke sare hain. So all of them are approximate, but none of them is exactly in the lower approximation, right? So we have these 2 classes. So every decision, agar yes, no decision hai, so every real decision is a real world concept. So every real world concept is approximated by 2 sets. One is the lower set and one is the upper set. So lower approximation and upper approximation. Lower approximation is those which fall completely inside the decision class, and upper approximation is that which just intersects with it, partially inside and partially outside. Okay. Right, and the boundary region is, this is the boundary region, the upper approximation minus the lower approximation. This is set minus, of course. Okay. So upper approximation is always a superset of lower approximation, and when we take the difference, that gives you the boundary region, and this is what we mean when we say approximate. अब मेरा दूसरा सवाल है. All this is fine. So engineering is all about optimization. And when I say I'm trying to reduce the attributes so that I'm able to classify, even though it is rough, so a very important question is, कि वो कौन से attributes हैं? Which are those attributes which I should select, to reduce it? So I don't want all the attributes. Yes, I want some of those attributes. And the optimization problem comes, therein comes the optimization problem. That which are those attributes? So for that we have, this parameter called accuracy of approximation. अभी तक आपने जब accuracy की बात सुनी होगी in terms of machine learning, we say accuracy of classification. accuracy of classification. Now here is an accuracy of approximation, which is the ratio between the lower approximation and the upper approximation. Okay? Now, do you think that there is some kind of a correlation between accuracy of approximation and accuracy of classification? क्योंकि अभी आपने देखा that when we try to make things too accurate, then we are not able to classify it at all. And when we try to reduce the accuracy by reducing the number of attributes, then we make an approximate classification, but the fact is at least we are able to classify. Now, isn't that an optimization problem? That shows that this is an optimization problem, और उस optimization problem में the important parameter is accuracy of approximation, which is this ratio. So somehow we have to be able to select those attributes or those redux which maximize the accuracy of approximation without compromising the accuracy of classification. Okay. So essentially, we are trying to maximize the positive region. This is the positive region, which is a union of all the lower approximations. Now we try our level best to try to enhance the positive region. Okay. So when we are talking about optimized redux, the question is which combination of features should form the reduct. Now this happens to be an NP complete problem. So मैंने within 1 hour that I have, one or 2 hours that I have today, I'll not be able to go into too much of details, but I'm trying to just motivate you so that you learn about them yourself. कि ये कैसे होता है, but then you have to understand that this is an NP complete problem. Somehow we human beings are excellent at it. अगर वाकई में मुझे एक जगह से दूसरी जगह जाना है during lockdown conditions, I somehow am able to find the most optimum results. But then here we have to do it mathematically. Okay. So the idea is to preserve the positive region. Okay. So if you remove some of the attributes, you may have to merge the indiscernibility classes. The equivalence classes needs to be merged. So you have larger and larger classes. Okay. So the lower approximation will obviously reduce significantly or just slightly reduce. So I have an approximate world. ये रहा. ये larger and larger होते जा रहे. Equivalence classes are becoming larger and larger. It's as if हमने कोई अजीब सा चश्मा पहन रखा है और दुनिया को approximate देख रहे हैं. So as if the whole world has got granularity, grains हैं और वो grain coarse होते जा रहे हैं, So redux preserve the positive region while making it more and more coarse. Okay. So when I say it is an optimization problem, there are some optimization goals, and those goals may be you search for the minimal redux. Minimal redux matlab jisme minimum number of attributes ho, or search for redux inducing a minimum amount of rules, or it is also possible that you have ensembles of redux, just like we have decision tree mein ensembles hote hain. So you find just not one redux, but a combination of redux, and you have different ensembles. Okay, so some of the algorithms are exhaustive, Boolean reasoning, greedy heuristics, genetic algorithms, attribute clustering. ये सारे के सारे algorithms apply किए जाते हैं to find out the optimum redux. ठीक है? So with that, I'll end the theory of this whole thing about rough set theory. अगर मैं एक if I summarize it in a few lines, rough set theory is all about optimizing the number of attributes which approximate real world concepts using some optimization techniques so that we have a reasonable accuracy of approximation and at the end a reasonable accuracy of classification. Okay, and we have all these algorithms to help us. Remember that rough set is a supervised technique. It is a rule-based technique क्योंकि हम rules बना रहे हैं. We have a database and we are trying to make rules out of them. It's a rule-based technique. It allows automatically feature elimination. As you're seeing that features are being eliminated. जबकि deterministic technique में typically you have a separate algorithm to reduce the features, like principal component analysis हम use करते हैं just to reduce the number of features. Here it is happening automatically. So automatically features are being also reduced. And also it is very much suitable for ensemble learning. Once again, only decision trees, when we are talking of deterministic techniques, so we make ensembles of decision trees. Yahan pe it is quite possible that you have ensembles of redux. All right. So with that, I'll come to one of the applications that we did with rough set theory. So what we did is we wanted to make a mini biography of important people. So Twitter में से काफी सारे data वैसे extract हो जाता है. So we thought then all those important people, the film stars and the politicians and all those socially strong, socially mobile people seem to put in a lot of tweets. So why not make a mini biography out of them? So auto extract the important tweets of a user, and we make a timeline identifying important events in a user's life. So for example, Amitabh Bachchan, we found a good candidate who keeps on writing कि मेरे ये हो रहा है, वो हो रहा है, मैंने अपने बहू के नाम पे ये खोला है, यहाँ पे जमी दी है, अब मैं ये मंदिर गया हूँ, this, that. They keep on posting all those things. So I said, fine, why not make a small biography out of him? And what we did is we had a timeline identifying important events in a user's life, and we made a small summary using the important tweets that were thus identified. So that was our motivation, that okay, let's make a mini autobiography, mini biography of the person. All right. So for that, we had to first collect the features, and so we thought when people post tweets, what are the features that we can extract? So in the Twitter environment, here is a Twitter user, say this is Shah Rukh Khan, and he writes such as to the best birthday party of my Farhan Khan, so and so, so and so, so and so. So he writes some post out there, and so this is the tweet. So that's the first thing we have in our hand. Why not summarize कि इस tweet में बोला क्या गया है? What is the content of the tweet? And then retweet shows that this is a popular tweet. Favorite count, retweet and favorite count. So retweets and favorite count tell how popular it is. And the replies, some people write replies, okay? So we thought that we have to find out some of the important features, and these were the important features that तो हमने table बनाया, जैसे मैंने rough set में बताया, we make a table. So we made a table of favorite count, replies to tweets, retweet count, and then these were the natural language processing part of it. So we wanted to find out the semantic relation, the correlation between tweets, and that was semantic relation. The web presence, for example, अगर अमिताभ बच्चन ने किसी अपने tweet में कहा है that I visited Akshardham temple. So Akshardham is something that has a web presence. So if there is a tweet जिसमें कुछ web presence है, it shows that it is important. And time impact. So time impact is how long people were interested in that tweet. Okay. So favorite count is very simple. It indicates the proactive interest of the community. मतलब कि लोग कितना favorites कर रहे हैं, उससे पता चलता है कि कितना proactive interest है उसमें. So then obviously it has to be part of the biography of the person if it is so important. Similarly, retweet means it's people are willing to share it with others, right? So when people are willing to share it with others, it shows that it is important. Then web presence, for example, wiki pages of hashtags identify web presence of themes, users' interest, right? So there are some hashtags which shows that which have a web presence also, and it shows the importance of the tweet. Number of replies, yes, कितने replies आए हैं उसमें. Time impact. Now time impact means if I tweet something today, for how long did it sustain users' interest? So what we did is we took the time between the posting of the tweet and the time of the last reply. Okay. Then semantic correlation, which is the semantic relationship between the tweets. How cohesive they were. So some person keeps on writing tweets. Are they all related to the same topic? So we used topic extraction techniques, LDA, latent Dirichlet association, and latent semantic indexing. ये topic extraction techniques हैं. तो उसमें से हमने देखा कि how much do the topics match with each other. So we used WordNet and NLTK to find out the correlation between tweets. So that is how we finally made the information. ये हमारा rough set theory का input होगा, right? और उनमें से favorite count we took as the decision, whether the tweet is important, unimportant, or middle important. So we classified into 3 classes: unimportant, important, and middle importance. Or so if the tweet had favorite count less than 10, then it was unimportant. If it is between 10 to 80, then middle important. And if it is greater than 80, then we took it as an important tweet. So this made our decision system for the rough set, for the rough set system. Okay. So we did the optimization. हमने वहाँ पे optimization genetic algorithm से लगाया. So we had to, as I said, the optimization is all about extracting the important features. And then we came up with certain rules. For example, so there is a left side to the rule and there is a right side to the tool. For example, if retweet is between anything to 17.5 and no replies were between, number of replies, not no replies, number of replies was between 0.9 and 4.3, and time impact was this, and semantic correlation was this, and wiki presence was this, then it is a medium tweet. So as you can see here, यहाँ पे all the features were taken. That means there was no reduction at all. This is possible when we don't have too much of data. If we have lots and lots of data, then there is a lot of feature reduction also possible. So we had a left-hand side a support, which is a support of the left side of the rule, and the right-hand side support, which is a support of the right-hand side of the. So we ultimately we derived the rules, and there were a large number of rules, which shows that there were a large number of, which shows that the redux were not all that approximate, and it is quite evident कि हमें सारे के सारे features देखने पड़ गए. But in some other cases like medical, we did other applications also. We did one on medical diagnosis. इस case में ज़्यादा reduce नहीं हुए थे. But there was another application which we did जिसमें medical diagnosis for psychological patients था, जिसमें बहुत सारे features थे. In this case, there were only 4 or 5 features, retweet, favorite, semantic correlation, and all that. But in the case of medical diagnosis, typically you have hundreds of features. So हमने, we were surprised to see कि psychological analysis of patients के लिए भी there are some 40-50 features that are important: motor skills, cognitive skills, emotive conditions, suicidal tendencies, and फिर ढेर सारे biological parameters. So there was a lot of feature reduction. Here, however, because the number of features per se was less, we found that all the features are important. Whatever, it was a good experience for us, and we came out with some rules, and ultimately, Amitabh Bachchan के tweets थे, so we found that a large number of unimportant tweets are there. Some of them were middle, and very few of them were important tweets. So there were 3 categories: important, medium, and unimportant. And as you can see that the background is unimportant, and there are some important tweets. With the same for Priyanka Chopra also, and we found that more or less similar patterns come. This kind of important, medium, and unimportant tweets were there, and finally we were able to calculate the precision, recall, and accuracy. And I'm sure that all of you know the meaning of these 3 parameters. कि कितने सारे tweets जो है वो सही classify हुए. We did a manual annotation. We did a manual annotation to find which were the true positives in this case. And what we found is that in the case of Amitabh Bachchan, the accuracy was so much, PC it was so much, and so onwards. Precision and recall. All right. So comparison of results on Twitter profiles. This was published also. This paper was published also. As it's an interesting, so what we did after that, I'm not talking, because after this we did an NLP, and we actually made a mini biography of Amitabh Bachchan and a mini biography of Priyanka Chopra within a certain time period. So the application was interesting, and it showed us that rough set theory can be applied. Okay, so this was about rough sets. If you have any question at this point, I'll be happy to address. And because I want to go on to say about some other approximation techniques and how we used it.
Ma'am?
Yes.
You have talked about the particular research work related to tweets. Right, ma'am?
Yes. Yes.
So, when we are talking about timelines,
Yeah.
so can we have that time series also included in this particular research work, first of all?
Obviously. Oh, yes, 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 surely. Because time series, there are so many parameters, the trends, the correlations. So all that come as features, right? So you see, machine learning is all about mapping real world concepts like yes, no, the decision with the features. And time series analysis gives a lot of features. So they can all be utilized as features. In our case, we just had to, we were doing NLP. So for us, the trend was not important. लेकिन अगर ये stock market prediction होता, अगर ये stock market prediction होता या bank rate prediction of bank rate interests, bank interest rates, इस तरह की कोई application होती, then definitely we would have applied time series. And it's a good idea. It's a good idea. I think you should try and do it.
Ma'am, I'm talking about tweets. When we're talking about tweets, in that particular case, I'm talking about this time series. How we can apply for this particular, in your case?
So in this case, if it is a time series and then we have some numerical parameters. See, right now, as I said, we were doing NLP, natural language processing. So basically, we were interested in the words, in the emotions. क्या words use किए उसने, क्या emotions use किए, क्या sentiments use किए. Now, sentiments, words, इनके it doesn't make much meaning to do a time series analysis. But supposing we had seen some numerical parameters, say we were trying to use the TF-IDF, right? We did not focus on TF-IDF. TF-IDF is the term frequency. तो अगर हम frequency terms के frequencies देखते और फिर देखते कि how they were varying along time, then we would have applied, then we can apply time series analysis. But we focused on the natural language processing part of it, and we saw the emotions that were there. So we did an emotion analysis, we did a sentiment analysis, and we basically saw the semantic correlation between tweets. So we were veering towards natural language processing. अगर हम उसमें कोई numerical parameters देखते, right? So definitely we can apply time series analysis.
But when we talk about this sentiments and this opinion, sometimes particular person says good things, sometimes says against some particular person.
Yeah. So you can keep on. So you make a numerical parameter like that. So you make a numerical parameter that what is the, for example, intensity of the negative sentiment or intensity of the. तो अगर the sentiment varies from -1 to +1 और फिर हमने देखा कि काफी देर तक for repeatedly there is a negative sentiment and that to -0.8 के करीब आ रहा है, and then after that it changes, then definitely and I'm happy that you've asked a question because now it is so important. अभी ये COVID का है, and in fact you have given me a good idea. That we want to understand how the sentiments of people are changing over the phase of COVID. शुरू से मार्च से लेकर के अब तक क्या continue हो रहा है, how the sentiments are changing and what is the trend. So it's a very good method if we can just do a time series analysis of how the sentiments are changing, intensity is changing. In this particular application that I talked about, our idea was to generate a biography of the person. तो बायोग्राफी में ट्रेंड एनालिसिस शायद उतना काम नहीं आता है. व्हाट इज इंपॉर्टेंट इज अलग अलग पर्टिकुलर टाइम. सो द इंपॉर्टेंट ट्वीट्स आर इंपॉर्टेंट, आइडेंटिफाइंग द इंपॉर्टेंट ट्वीट्स और उन इंपॉर्टेंट ट्वीट्स में किसके बारे में बताया जा रहा है, दैट वाज इंपॉर्टेंट. बट इफ यू वांट टू डू एन एनालिसिस ऑफ पूरे कम्युनिटी में, पूरे दिल्ली में या पूरे वर्ल्ड में सेंटिमेंट्स कैसे चेंज हो रहे हैं एज the COVID-19 is progressing, then time series analysis will be a good idea to apply.
Right, ma'am. Thank you, ma'am.
All right. Anyone else? Any other question? So, but then do you get the whole idea about rough set theory? it's rough set and fuzzy logic are now being combined in this approximation paradigm. बहुत सारे interesting combinations are occurring.
Madam, in that you talked about this particular case about ensemble learning.
Yeah, yes.
So when we talk about ensemble learning, we talk about deep learning.
Ensemble is actually a group of experts, and when we say ensemble, it is so it can be applied in various methodologies. Like decision tree may be hota hai. You have very short trees, very small trees, and an ensemble of those. So essentially, in an ensemble, individual experts are very simple. Together, they become powerful. So it can be in deep learning also, it can be in decision trees also, and you can also make a combination of these techniques. But then, machine learning का पूरा किस्सा ही वही है कि overfitting versus underfitting. यहाँ पर भी we have seen over approximation versus no approximation. So in the case of fitting, we know कि fitting का मतलब क्या है कि एक example को छू रहा है वो ना, it is touching every example. So, but here we are already talking of approximation. So we are now talking about over approximation and under approximation. So when we have ensemble learning, we make each and every individual as approximate as possible. The individual experts are very approximate. Yani ki, each expert has a few attributes to work on. So the redux are small. Just like decision tree, if you know about decision trees, ensemble in decision trees, you use stubs, what we call not the trees but the stubs. एक या दो level के होते हैं, right? So each individual decision tree is a very simple model. Simple मतलब overfitting नहीं होगी. Underfitting फिर भी हो सकती है पर overfitting नहीं होगी. Okay, so it's generalization. यहाँ पर भी ऐसा ही हाल है that we have redux which are quite approximate and therefore they are able to classify. किसी न किसी तरह से classify करेंगे हालांकि accurate नहीं करेंगे. But when we put them all together, then the whole thing becomes a very powerful expert, and not only powerful बल्कि without any overfitting. So here also rough set theory allows you to make approximate redux and an ensemble of them. तो किसी ने जैसे मैंने कोविड का एग्जांपल लिया ना, कोई देखेगा कि जो डेस्टिनेशन सिटी के सिटीजन्स है हाउ सेफ दे आर इन देयर प्रैक्टिसेस, कोई कुछ और देखेगा, कोई कुछ और देखेगा. सो देयर आर अ लॉट ऑफ फीचर्स एंड सम ऑफ अस will see some of the features, some of us will make some other feature, and together it makes a strong expert. Okay.
Ma'am, one more different thing I want to ask. You have used this NLTK and WordNet.
Yes.
Right,
in this
and LDA
yes.
You have used.
We have used an LDA for topic extraction.
For topic extraction, right. So what is the relevance that we are not going with deep learning? We are going with these things.
Yes, that's a good question, because people are so fixated with deep learning now. So deep learning is a very powerful method, no doubt about it. And deep learning and transfer learning now are increasingly being used by more and more researchers. Again, no doubt about it. But इसका मतलब ये नहीं कि these techniques, that's why I deliberately took up these techniques. I could have taken deep learning and all that. But I have deliberately taken these techniques because they also have a relevance. They are computationally very simple and computationally elegant, and they don't require that much of training or that much of input data जिसमें बहुत लंबा training time लग रहा है. And what is more, in many cases, we don't even have that much of data. Machine learning is all about learning from data. And in many cases, we don't have so much of data. So when we don't have much data, then deep learning methods really don't make sense. In deep learning, it's all about having more and more data. Okay, though people are trying to circumvent that also now, but essentially you need to train so many weights, and when you need to train so many weights, the availability of data. मतलब Google के पास अगर इतने सारे images हैं, so much of computational power hai. They have excessive computational power and they have excessive data. So they are able to train their models. उसी model को हम लोग adopt कर लेते हैं by changing the last few layers. But there are so many applications जिसमें इतना data होगा ही नहीं. How can you apply deep learning there? So these techniques have their own elegance, and खास करके these probabilistic and approximate techniques are actually quite powerful, and not everybody uses them. We use all deterministic techniques, whereas these techniques are computationally elegant and applicable to many domains and applications. So ये है. So whereas I will not discount deep learning, it's very powerful, yet it is important to realize that these methods are also not passé. इनको हम hot potato की तरह drop नहीं कर सकते हैं. They are actually useful. So everybody seems to be in a race for using neural networks. There's no need.
Right. Thank you. So kind of you, man. Because I just used to confuse with these two concepts whenever we used to talk about machine learning and deep learning.
Yeah, exactly. अब तो ऐसा लगता है जैसे synonymous हो गए हैं. But they all these techniques have their own relevance, and we must use them. Okay. So Manish, do I go further or do I end it up? I have certain things which I wanted to talk about. If you say, I'll do. Otherwise, we'll wrap it up. So these were some probabilistic. Do you know of hidden Markov models? It's the time. 10:04. So hidden. So Manish, what do you say? Should I go a little bit ahead? Maybe some 15-20 minutes.
Yes, ma'am. You can go, ma'am.
All right, fine. Thank you. Okay. So I'll also talk about another type of model which are probabilistic. तो जहाँ rough set approximate method है, fuzzy imprecise method है. तो ये देखो ये सारे all these paradigms are there. Approximate methods, imprecise methods. There are also some probabilistic machine learning techniques. And hidden Markov model is one such technique. So what is hidden and what is evident? Markov, you all know. Markov means it is dependent only on the past state, on the current state, and not on the previous state. The next state is dependent only on the current state. So you have transitions like this, and you have hidden transitions. ये पूरे के पूरा upper portion is hidden, and what we see is only an observation. The rain or dry. So we don't know what's happening in the atmosphere. High pressure है, low pressure है, क्या है. So let's say that we have a low atmospheric pressure and then switching over to high atmospheric pressure, और ये अंदर ही अंदर हुए जा रहा है, and we don't know. We only see whether there is rain or dry. So what happens is we have an observation sequence like this: rain, 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 dry, rain, 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 dry. इस तरह से हमें दिख रहा है. And what we want the machine. So now you see. Now you see what's happening here. We talk about deep learning and we talk about all those kind of techniques जो कि time को नहीं consider करता है, you know. So wherever there is sequential, time wise, अभी आपने time series की बात कही. All right. Time may, if there is some probabilistic change, now this is completely a probabilistic change that is happening. So in time steps, if there are probabilistic events happening, then the Markov models become very useful. Okay. So hidden Markov model, the challenges given such an observation sequence are the following. You assess those patterns, that means predict or classify by calculating the overall probability of different observations. मतलब अब तक का ये sequence है, तो आगे क्या sequence हो सकता है? That is one of the challenges. Second is detect the hidden state sequence. That means if you see this observation sequence, what is probably the hidden state sequence? And that is very, very useful in pause tagging. Part of speech. So when I talk about part of speech, what we see, the evident part of it is the words. For example, I'm speaking now. I am speaking now. ये आप सुन रहे हैं, मैं बोल रही हूँ और आप ये सुन रहे हैं. ये observation है. I am speaking now. 4 words हैं, and you are able to hear. But somewhere within, it is a part of speech which is changing. I is the subject, am, speaking are the verbs, now is a qualifier. So can we have a hidden Markov model which will automatically tag the part of speech? So that is finding the latent जो अंदर जो दिख नहीं रहा है उसको evident करना is the second challenge of HMM. And the third challenge is building a model for a sequence. आपके पास एक sequence है, for example, let's say the sequence is the sequence is weather. Weather temperature. So let's say we have these HVAC systems. HVAC, do you know what are HVAC systems? The air conditioning systems with humidity, ventilation and air conditioning, HVAC. तो आजकल सारे ऑफिसेज में सेंट्रली एयर कंडीशनड होता है जिसमें HVAC सिस्टम्स लगाई जाती हैं. एंड वन ऑफ द इम्पोर्टेंट प्रॉब्लम इज कि वो HVAC सिस्टम्स के जो थर्मोस्टैट सेटिंग्स हैं, द डिफरेंट कंट्रोल्स, द वाल्व सेटिंग्स, वो हाउ कैन वी चेंज देम ऑटोमेटिकली? सो व्हाट दे डू इज they make HMMs for every, say, 4 hours. So they see the inside temperature, outside temperature, inside humidity, outside humidity, and so onwards. And then they make a hidden Markov model for every 4 hours. So when the weather changes, you try to classify कि अब आगे कौन सा HMM आएगा, and therefore you set the settings accordingly. So the third challenge is to build a model. Given a classification, given an observation sequence, build a model. Okay. So it has a number of applications like sequential pattern recognition, pause tagging, abhi maine bataya. Gene prediction mein HMMs are used very widely. Object recognition in video. Video is also a sequence. Handwriting recognition, again a sequence. Named entity recognition. All right. Okay. So we have, when we talk of an HMM model, there are 3 things there. इस पूरे केस में, one is the starting probabilities, as there are 2 states, so the starting probabilities of the states, then the transition matrix, which is एक state से दूसरे state जाने की transition, so these are probabilistic transitions, and the output matrix, which is the probability for each state producing different outputs. All right, state 1, state 2, output rain, output dry, और इनकी probabilities. अगर ये 3 matrices मेरे पास हैं, then I have an HMM which describes a probabilistic sequential process. Okay, so the problems that HMM solve is evaluation problem, which is given an HMM and an observation sequence, calculate the probability that this model has generated the sequence. The second is a decoding problem. Given an HMM and an observation sequence, calculate the most likely hidden state. अब हम probability of output नहीं कह रहे हैं, probability of the hidden state that produced this output. तो जैसे मैंने example दिया pause tagging का. Then learning problem, given an observation sequence and the general structure of the HMM, for example, the number of states, determine the HMM. तो इन दोनों में HMM already presumed है कि already आपके पास है. And third is आप synthesize कर रहे हो, you are synthesizing a Markov model, right? To summarize, this model, the HMM model, is a generative model. It is not a discriminative model. It is a generative model that generates infinite samples of outputs and either does evaluation or decoding or learning, and of course it does optimization. To do all these things, it has to do some kind of dynamic programming use hota hai. Typically dynamic programming बहुत use hota hai, and it does some kind of local optimization to do all these functions. तो एक एग्जाम्पल once again एक एप्लीकेशन ही मैं दे सकती हूँ इस वक्त. तो फॉर एग्जाम्पल ये वर्ड है, ये टाइप्ड वर्ड है और आपको ये निकालना है कि व्हाट इज द वर्ड. So this is text recognition, you know, written text recognition. तो कौन सा कैरेक्टर यहाँ पे आया है, that's what one has to recognize. So अगर A लिखा है, this is the observation. It is a hidden Markov model because this is the observation. You are seeing this pattern is the observation, and the hidden state can be one of these alphabets. ओके सो इस पर्टिकुलर स्टेट में ये आउटपुट प्रोबेबिलिटीज हैं, ये आउटपुट प्रोबेबिलिटीज हैं. So if I want to recognize the word, then so let's skip this. I'll take up this one. So either you have a lexicon. Lexicon is a collection of words. तो ये एक word है Amherst, ये एक word है buffalo, right? And I have a collection of such words, and I have a hidden Markov model for each word. Like, these are the transition. This is the state, hidden state. Observation ये है और ये hidden state है. तो हर hidden state के ये output produce करने के probabilities मेरे पास है. In addition, इनकी transition probabilities भी हैं, right? So therefore, when you have a new word like this, Amherst, written in text, all I have to do is कि इन सारे words में से कौन सा HMM best match करता है, which is the best matching HMM. So the whole problem is about recognizing the word images by evaluating a few HMM models. Now this is an application of evaluation problem कि output ये वाली output overall ये वाली output probability क्या है, overall ये वाली output probability क्या है. So you see it is this first problem, evaluation problem. What is the probability of an output sequence? Okay, so that's what we are seeing, a probability of this output sequence, probability of this output sequence. Another way of word recognition is that you don't have a lexicon, you have a collection of all these letters, the individual alphabets, and you have one single HMM which is called the language model. So this language model is built by having a large corpus, dictionary है आपके पास और World Wide Web के जितना whatever words are written, from that you make this kind of an HMM. कि what is the transition probability between the alphabets? ये आपके पास है. What is the transition probability between alphabets? So and likewise, what are the observation probabilities? यहाँ दिखाया नहीं है, but what are the observation probabilities? So I have a single HMM for the entire language called the language model, and here we have to determine. So this अगर कोई text है मेरे पास like Amherst है या कोई buffalo कोई word है, then I must find out the best possible hidden state sequence. Now this is the decoding problem. Here we have to determine the best sequence of hidden states, the one that most likely produced the word image, and this is the decoding problem. Okay. So I'll not go any further. I've given two applications for HMM, and HMMs are highly used for speech synthesis, speech recognition, typed word recognition. तो इस तरह से and POS, pause tagging, and for gene decoding. They don't use deep neural networks there at all. We don't use deep neural networks there. So we rather use HMM for those kind of applications. And finally, I'd like to talk about this conditional random fields, which is also a Markov model, which is also a probabilistic model, but this is not a generative model. This is a discriminative model. So here again, here you see, unlike the HMM, the hidden Markov model, you don't have this thing, arrows. So this is undirected edges here. And also, उसमें transition probabilities fixed होती थी. If you see here, the transition probabilities were all यहाँ पे. Here the transition probabilities were numbers, right? So CRF is a more powerful model and a much more powerful model. A much more powerful model जहाँ पे ये जो alphas हैं, these are the learning parameters. तो वहाँ पे, as I said, the transition probabilities and the output probabilities is what the machine needs to learn. Here it is this alpha and the function here, this function. This replaces the transition. So the transition probability is not fixed, but it is a function of yi with yi minus 1, so nearest neighbor, and also the words which are called the observations here. This is the output. These are the observation, and this is the output labels. तो for instances ये word हो सकते हैं और ये इनके pause tags हो सकते हैं, noun, verb, adjective, and these are the actual words. तो इनका कोई function होगा, together मिलकर के कोई function होगा. That replaces the transition and the output probabilities. So this is a function and therefore it is much more powerful. Because of this power, conditional random fields or CRFs allow us to take into account the context, which HMM doesn't. Okay. So the entire paragraph की context क्या है? So it's able to do classification based on context, and we have used it for detecting metaphors in language. And it was an interesting application. We thought we will. So you know what's a metaphor, na? A metaphor. All men. अगर biology में एक professor ने कहा all men are animals, this is not metaphorical. He actually meant that men are animals. But after her spat over parking, she said all men are animals. So किसी lady ने parking में कुछ face किया, and then she says all men are animals. This is possibly metaphorical. She doesn't have some metaphors and some non-metaphors, and we applied CRF to it. So again, we had these features. I'll not go into much detail. Syntactic features, conceptual features, affective features, contextual features. So we take all these features. Syntactic, you know, is a grammar, the grammar part of it. Conceptual is, you know, psychological. So MRCPG is a psychological database, and WordNet, इससे हमने conceptual features निकाले. Affective, as you know, is emotions, like emotive content of the words, and contextual is we took embeddings. So we can take word embeddings, and word embeddings is contextual. So इस तरह के features लिए और सारा डाला CRF के अंदर. So we put it into the CRF for metaphor detection, and we trained the model, okay, and finally it came up with metaphor detection. So we used CRF for the first time, and this paper was also published in a prestigious conference. So we gave all our results. So these are the syntactic features, lemma part, ये grammatical है, dependent, named entity type, stop word, ये सब है syntactic में. Conceptual में things like imageability, meaningfulness, concreteness, familiarity. ये ना ये MRC medical you know psycholinguistic database है. तो वहां से ये सब पता चलता है हर वर्ड की इमेजिबिलिटी कितनी है. एवरी वर्ड हैज एन इमेजिबिलिटी. इफ आई से डिग, you will have an image of it, but if I say laptop, you'll have some image of it. So every word has some imageability, concreteness, meaningfulness, and these are given in this database. We took it from there. Affective is something like emotional state क्या है उस word की, joy, anger, attitude, trait, personality trait, physical state like bodily physical state क्या है, cognitive state, feelings है, sensation है. So it's interestingly a lot of these databases is already there. So we used WordNet effect. We used MRCPD for that, for the conceptual, and for affective we used WordNet effect.
Hello. Hello, ma'am. Your voice is not audible.
Okay, since when is it not audible?
Okay. Your voice is coming, ma'am.
Manish, am I audible? I can't hear you.
Yes, ma'am. Yes, ma'am. You are audible.
Okay. Okay, so I'll wrap up because now there's hardly anything left. I
Okay,
was talking about, yeah, I was talking about this application where we were trying to detect metaphors. Yeah. So I was just talking. Are you able to see the slide?
yeah, we can see, ma'am.
The graph, that is it a graph? Yes.
No, it is not a graph. It is a inferences.
Inferences. Okay, then there's some other window. 1 second.
Okay.
ये कोई और window आ गया. This one. No, it's still not coming.
Still not coming, ma'am. Okay. Yeah, this is it. Is it okay Oh.
now? Can you see the?
Yeah, yes, ma'am. It is okay.
I was talking of yeah. So I was talking of metaphor detection, and by combining various features, we were able to get this kind of an F measure. The F measure is a harmonic mean of recall and हमने ये interesting चीज जो पाई है वो ये है. So this is using CRF, conditional random fields for metaphor. The inferences we found that basically we wanted to see whether emotions can be used to detect metaphors. We found that only a very small percentage of effective words are there in the data set, and 24% of them are metaphors. Okay, we compared the CRF approach with SVM approach, and we found that CRF approach has definitely got very good accuracy, though the precision of SVM was better. So अलग-अलग techniques होते हैं. SVM is one technique, CRF is another technique. But what interestingly we found that since metaphors occur sequentially in the language, probably HMM and CRS will work, and they did work. Okay. So the conclusion we made is a diverse feature set is useful in detecting metaphors, and CRF-based approaches provide a more precise and good coverage. However, SVM has better recall than CRF. All right. And we found that the issue of open category words in long sentences, this is something that needs to be still analyzed. We did that as a subsequent work. The reason why I'm presenting this to you now is to show you that deep network is not the end of the world. You need CRF, and you need probabilistic and approximate approaches to tackle different kinds of problems. So with that, I'll end my lecture, and hopefully I've given you some flavor of machine learning techniques using alternative.
Yes, ma'am. Participant want to ask any question?
Yes. Anybody?
Okay. Anyone want to ask? Just raise your hand. Okay, thank you, Professor Shampa, ma'am. I, Manish Kumar Sharma, on behalf of Department of IT, ABS Engineering College, Ghaziabad, a very heartily vote of thanks to you, gracing the event with your presence and sharing with us your finding and opinion about the rough set theory in machine learning. Thank you, ma'am.
Thank you.
Thank you all.
Thank you so much. Thank you. Have a good day.
Participant, please. Thank you, ma'am. Participant, please fill the feedback form. Thank you all.
Can I leave now,
Okay.
Manish?
Yes, ma'am. You can leave, ma'am.
Okay.
I am sharing the feedback form. Participant, please fill the feedback. Now I am going to end the meeting. Thank you all.